Hi learners! On this video lesson, you will learn the different types of angles based on measure. Determining these types of angles without actually measuring them is demonstrated with the use of fixed angles and familiar objects as benchmarks. How to measure the angle with the use of the protractor is also demonstrated. Angles in real life are shown to make the concepts relatable and meaningful. Strategies in analyzing and answering word problems related to the topic are demonstrated to let you gain an understanding on how these are done so that you'll be able to successfully answer geometry problems similar to these in the future. If your lesson is on type of angles based on measure, or if you have an assignment on this topic, or if you're preparing for a test in math, or a test in geometry in particular, or you're someone who's interested in learning math, then this video is for you. Having that said, please support the channel by giving a like. If you have not already done so, hit that subscribe button and share this video as well. Thank you. It will definitely help this channel. Now into our lesson. I want you to look at these learners. What do you see? You're correct. Here are two rays, one on top the other. Now watch these learners. What did you just see this time? You're correct again. A space or opening between the rays is created, indicated by the arc, as one ray is rotated around their intersecting endpoints. What we have is an angle. The angle has two rays with the rays endpoints intersecting. The rays are the sides of the angle, and the intersection of their endpoints is the vertex of the angle. Where do we see angles in real life? The truth is they are everywhere. Here are examples of real-life angles. Some are marked with arcs for clarity. You see them inside the house, like the corners of the tables and other appliances, where the floor and the wall meet, the corners of doors and windows, to name a few. You see them outside the house, the roof of a building, the branches of trees, the intersection of the tree and the ground. You see them just everywhere and anywhere, on art displays, streets, power lines, etc. By the way, what have you noticed about the size of the opening of the different angles that you have just seen? You're correct. The size of the opening varies. The measure of the opening corresponds to the measure of that angle. Talking of measure, I want you to think of the measure of the angle as the amount of turn of one ray while the other ray is steady. Let us label the side that turns as the terminal side and the side that is steady as the initial side. Now, you must realize that the bigger the turn of the terminal side, the larger the angle is. A protractor is one of the several instruments used to measure the size of an angle. Though there are several units of measures for an angle, the degree unit will be used for the angle measure on this video lesson. The common protractors are the semicircular protractor, measuring a maximum of 180-degree turn, and the circular protractor measuring up to 360-degree turn, a full rotation. Though they have different shapes, both contain the same important features: a center point, a baseline, and scales in degrees. To visualize angle sizes or how big the measure of an angle is, let us look at the protractor again. We will familiarize ourselves with some fixed angles that are easy to remember and use them as benchmarks. Look at these learners. What did you just see? You're correct. A 90-degree angle is created. Let us put the box inside the angle to indicate the 90-degree angle measure. What letter in the English alphabet resembles this angle? You're correct, letter L. This angle also resembles the corner of a piece of paper as shown. Do you see it, learners? So an L-shaped angle has a size of 90 degrees wherever its opening is facing. You have to remember this, learners. Let us label the initial and terminal sides of our L-shaped angle. Now, if this is the angle having a 90-degree measure, what is the measure of this new angle? Comparing the position of the terminal side of the new angle to that of the 90-degree angle where the rays resemble an L, the terminal side of the new angle is closer to the angle's initial side. What does the position of the terminal side of the new angle say about its measure? Is it less than 90 degrees or greater than 90 degrees? Okay, so the measure is less than 90 degrees. Now, what about these learners? On here, the terminal side of the new angle is now farther away from its initial side compared to the terminal side of the 90-degree angle where the rays resemble an L. So, what is the measure of the new angle? Is it less than 90 degrees or greater than 90 degrees? Okay, so it is greater than 90 degrees. Can you follow, learners? Let us look at these learners. What do you notice about the sides of the angle? Correct, they form a straight line. What measures does the protractor show for this type of angle? You're correct again, 180 degrees. So an angle resembling a straight line has a measure of 180 degrees. Now, turning the terminal side of this 180-degree angle as shown, what do you think is the size of the new angle? Is it greater than 180 degrees or less than 180 degrees? Okay, so here, the terminal side of the new angle is now closer to its initial side compared to that of the 180-degree angle, the straight line angle. So, the measure of the new angle is less than 180 degrees. Now, what about this? What do you think is the size of the new angle this time? Is it greater than 180 degrees or less than 180 degrees? Okay, so comparing the terminal side of the new angle to that of the straight line angle, the 180-degree angle, the terminal side of the new angle is now farther away from its initial side. So the angle measure is greater than 180 degrees. Did you get it, learners? Okay, now look at this, learners. What did you just see? You're correct. One ray rotated from 0 degree to 360 degree, a complete turn, creating a circular space resembling a clock. This angle resembling a clock is the 360-degree angle. There you are, learners. The letter L, or the corner of your paper, is the 90-degree angle. The straight line is the 180-degree angle, and the face of the clock, a complete turn, is the 360-degree angle. Remember these benchmarks when visualizing the sizes of the angle. Now, let us get the exact measure of some angles shown earlier using the protractor. Let us start with this angle. To measure the angle, choose first the angle's initial side. Let the initial side be the ray pointing down. Then, place the protractor's center point directly on the angle's vertex. Next, rotate the protractor so the baseline is on top the initial side. The initial side is where the 0-degree reading of the angle is. From the 0 mark, move away from the initial side following the curved scale with an increasing measure until you locate the point where the terminal side of the angle crosses the scale. Read the degree mark where it crosses the curved scale. This is the measure of the angle. The angle measure here is around 67 degrees. Next, we will get the measure of this angle. This time, we will choose the ray pointing up as the initial side of the angle. Then place the protractor center point directly on the angle's vertex and the baseline on top the initial side of the angle. This is where the 0 degree of the angle is. From the 0 reading on the initial side, move away following the curved scale with an increasing measure until you locate the point where the terminal side of the angle crosses the scale. Read the degree mark where it crosses the curved scale. This is the measure of the angle, 144 degrees. Did you get it, learners? Finally, we get the measure of this angle. This time, we will use the circular protractor and consider the ray on the left as its initial side. As usual, place the protractor center point directly on the angle's vertex and the baseline on top the initial side of the angle. This is where the 0 degree of the angle is. From the 0 reading on the initial side, move away following the curved scale with an increasing measure until you locate the point where the terminal side of the angle crosses the scale. Read the degree mark where it crosses the curved scale. The angle measure is 235 degrees. There you are, learners. Now, what did you notice about the measures of the different angles? You are correct. The measure of the angles varies. Hence, one of the many classifications of angles is based on measure. I am sure several of you have heard or have worked on maybe 4 common angles in your previous math subjects, but today we will name 7 types of angles based on measures. Yes, 7. The table that follows displays the 7 types. First, 0 angle. The angle that measures exactly 0 degree. Here, not one of the rays turned. A drawing is shown. Second, acute angle. The angle that measures greater than 0 but less than 90 degrees. Check the sample drawing here and compare the terminal side of the acute angle to that of the L-shaped 90-degree angle. Third, right angle. The angle that measures exactly 90 degrees. The angle representing letter L. Fourth, obtuse angle. The angle that measures greater than 90 degrees but less than 180 degrees. Check the sample drawing here and compare the terminal side of the obtuse angle to that of the L-shaped 90-degree angle. Fifth, straight angle. The angle that measures exactly 180 degrees. Look at the drawing. This is the angle whose rays form a straight line. Sixth, reflex angle. The angle that measures greater than 180 degrees but less than 360 degrees. Check the sample drawing and compare the terminal side of the reflexed angle to that of the straight angle, the angle whose sides form a straight line. Seventh, complete angle. The angle that measures exactly 360 degrees. Check the drawing. Here, one ray made a complete turn resembling the clock. Okay, let us now have sample problem 1. Here is the problem. Identify the type of angle marked with an arc on each number based on measure. Part 1. The figure below shows a roof valley. A roof valley is the V-shaped intersection between 2 sloping roofs joining at an angle to provide water runoff. What type of angle is formed by the roof valley shown by the arc below? Option A, acute angle. Option B, right angle. Option C, obtuse angle. Option D, straight angle. Option E, reflex angle. Part 2. The figure below shows a portion of city streets. What type of angle is formed by the streets marked with the blue rays? Option A, acute angle. Option B, right angle. Option C, obtuse angle. Option D, straight angle. Option E, reflex angle. As usual, we begin by reading the whole problem and may read it several times when needed to know what we're looking for, to determine what are given, and to figure out how the given information help find what we're looking for. Okay, what is asked in the problem, learners? Sample problem 1 has 2 questions. Both ask for the type of angles formed by the given photographs. Okay, let us start with part 1. The angle formed by the roof valley. What is given? A photograph of the intersection between 2 sloping roofs showing an angle marked with an arc is given. To answer the question, we have to recall the different types of angles together with our benchmarks for visualizing the size of the angles. Our letter L for 90-degree angle and a straight line for the 180-degree angle. Now, do the sides of the angle represent an L or a straight line? Okay, so not an L nor a straight line. It is between the two, which means a measure greater than 90 degrees but less than 180 degrees. So, what is our answer, learners? Is it option A, option B, option C, option D, or option E? Okay, so the answer is option C. To check, we can get the measure by using a protractor. With the protractor, this has a measure of about 132 degrees. So, it is indeed an obtuse angle. Now, on to part 2. Again, a photograph is given, this time that of city streets. To answer the question, recall again our benchmark, L for 90-degree angle. Now, is the shape of the angle an L? Okay, so no. The terminal side of the angle is closer to its initial side than the terminal side of the L-shaped angle, the 90-degree angle. So, what can you say about the size of the angle? The measure is less than 90 degrees. What then is our answer, learners? Is it option A, option B, option C, option D, or option E? Okay, so the answer is option A. Again, we can check by actually measuring the angle with a protractor. Learners, I will leave that to you. I'm sure you can do it. Let us move on to sample problem 2. Here's the problem. Given the figure below, estimate the angle measure and tell what type the angle is. Option A, 80 degrees, acute angle. Option B, 110 degrees, obtuse angle. Option C, 180 degrees, complete angle. Option D, 210 degrees, obtuse angle. Option E, 360 degrees, complete angle. As usual, we begin by reading the whole problem and may read it several times when needed to know what we're looking for, to determine what are given, and to figure out how the given information help find what we're looking for. Okay, what is asked in the problem, learners? Here, we are to determine the type of angle shown and to estimate its measure. What information is given? A figure of the angle is given. Is a protractor necessary to answer the question? Not really. We simply need to recall our benchmarks. If the two rays form an L, we have a 90-degree angle. If the rays form a straight line, we have a 180-degree angle. Look at the figure. Is it an L or a straight line? Okay, so neither. It is an angle with a measure greater than 90 degrees but less than 180 degrees. So, if it is between the two, what type of angle is it? You're correct. It is an obtuse angle. Now, let us check the options to get the estimate of the measure. The angle is an obtuse angle, so it is not option A, not option C, not option E. It is either option B or option C. Now, an obtuse angle is a measure that is greater than 90 degrees but less than 180 degrees. What then is the answer, learners? Okay, so the answer is option B. Its measure is 110 degrees and is an obtuse angle. There you are, learners. That was again easy. I hope that you acquired lots of learnings in today's video. Let us summarize what we have learned today. We have learned that, first, an angle is a shape with rays as its sides and the intersection of the rays endpoints as its vertex. Second, the measure of an angle can be thought of as the amount of turn or rotation of one ray, the other ray being steady. Third, a protractor is one of the several instruments used to measure the size of an angle. Fourth, the types of angles based on measure are zero angle, acute angle, right angle, obtuse angle, straight angle, reflex angle, and complete angle. Fifth, when solving a problem, you must read it and may read it several times when needed to know what you're looking for, to determine what are given, and to figure out how the given information help find what you're looking for. Sixth, when a figure is given, make use of it and modify when needed. It is there to help you analyze and solve the problem. There you are, learners. Hope this video helps. That's it for now. If you have any question, leave a comment below and don't forget to like, subscribe, and share this video to your peers so others will learn too. Bye.